Digital twins have long promised transformation, but most are limited to static visualization and almost always fall short of what's actually needed. Those legacy tools can't keep pace with the speed and complexity of today's grid, which requires a new level of visibility, intelligence, and coordination to manage and operate effectively. Utilities need purpose built models that simulate how assets behave and interact under real world conditions to get a living, dynamic view of the grid. To meet this challenge, utilities are turning to advanced physics based virtual models of their physical grid assets and systems, working in tandem with the operational data ecosystem and integrated applications to form the new generation of digital twins. At its core, a digital twin unites high fidelity, AI ready operational data with advanced engineering simulation. This combination of data and physics allows utilities to analyze system dynamics, test operational scenarios, and plan for future conditions within a single environment. In this example, you can see how a pole is reacting to various NESC and GEO95 simulated conditions based on NERA's finite element analysis to test the stress at each component within the asset and how it will impact the poles connected to it. This can be scaled across a feeder or circuit, or across the entire network to identify risks and fragility involving structural utilization, vegetation management, wildfire ignition risk from clearance issues, and asset failure predictions. The physical asset digital twin enables teams to answer critical what-if questions across these applications and timescales, from hours ahead to months and multi-year planning horizons, allowing them to identify fragility at scale and optimize where investments are directed. NERA can answer questions like, where is it most cost-effective to underground or install covered conductors? Which poles should be replaced, upgraded, or reinforced to extend asset life? How can we quickly assess network utilization to plan upgrades and their resulting downstream impacts using our design rules and libraries? These insights are propagated up and downstream through the integrated digital twin, spanning electrical flow modeling, operational twins, and connected data systems. Each scenario is grounded in asset-level clarity and rolled up to a unified decision layer that informs process integration, strategic planning, and regulatory rate case support. When integrated with enterprise systems like GIS, ADMS, and work order management, the digital twin becomes the core engine of a utility's digital ecosystem. Digital twins help utilities improve reliability through faster situational awareness and restoration, minimize wildfire risk with targeted PSPS and ignition prevention, and enhance operations by creating a single, shared model across planning, engineering, and field teams. By aligning around a single source of truth, the digital twin drives faster decisions and reduces operational friction. With an integrated digital twin, utilities can reimagine how they plan, operate, and invest for a more resilient future.